talk about, let's make sure this is recording. Yep. So let's talk about the final. So for starters, the final exam is, let's make sure we all agree on the day, Tuesday at 10:10 a.m. That sound accurate? Okay. Tuesday at 10:10 a.m. So let's go here. Tuesday, 10:10 a.m. All right, so you'll have the full 2 hours or whatever. Yeah, 2 hours to take the exam, or an hour and 50 minutes. I think, what is it, 2:10 till 10:10 till noon, or the time period. So I'll design the exam to take about an hour. So it should be kind of a similar length exam to the midterm, about the same kind of time period, but you'll have more time to spend on it. So take your time. There should not be a if you're prepared for it, it should not be something that you're stressed on time with. So the exam will be about 70% non-programming, 30% programming. So there'll be probably 2 to 3 questions, probably 3 programming questions on the exam. Usually my exams have 10 questions on them, give or take. So let's say 30% programming, 70% other. Programming questions, like I said this before on the first exam, I'm not looking for perfection, I'm looking for competence. So, if you make a small little error, you forget a curly brace, or, you put a semicolon where you're not supposed to, I'm not taking off points for that. That's obviously something the ID is going to catch and scream at you about, and then you'll go and make the quick little change and that stuff. So I'm not looking for that. I'm looking for overall competence. Do you pretty much know what you're doing, or do you definitely not know what you're doing? And typically it's one of those two. So if you've been working hard on the homework assignments, whether you're working in a group or doing it completely solo, doesn't necessarily matter as long as you're getting what you need to be getting out of it. Okay? So while I still expect for many of you it might be difficult for you to just sit down and do the homework assignment without some hand-holding, you should feel like you're more capable of doing that now than you were at midterm. That's one step. And the other piece is that at the very least, you should be able to write large chunks of the solution yourself, kind of like, that's a pretty good attempt, but this is where you went wrong, instead of you basically throwing up on the screen. If you kind of get what I'm saying. So from a professor's perspective, it's usually pretty clear whether you have a clue what's going on or whether you don't. So you're not going to get partial credit for like writing the word int, that kind of stuff. If you've written some code that looks like you pretty much know how to program, then that would be fair. I could see there being hello world on there. That would not count as a programming question, just to throw that out there. That's a memorization question. Okay? So that would not count as programming if it makes an appearance. So it all depends on the mood or what pops into my head when I'm writing this. Okay, so as you're writing your solution to the programming part of the exam, what I'm encouraging you to do is try to show me that you generally know what you're doing when it comes to writing code. Right? If you're having some problems with the exact algorithm you should use for this one, kind of make your best pass at it. Write me a couple of lines of English that says, this is how I was trying to approach it. I kind of got stuck on this part. Almost give me your self-evaluation like you do for your homework assignment. Okay? So I'm going to take that into consideration because there's 2 different sides to that. One is, how are you coming along from a problem-solving perspective? The other one is, how is your competence coming out in terms of actually writing the code? If you put this in natural language, in a natural language example, it's tell me what you're trying to say, then show me the English that you think you need to say to explain it. Okay? And then between the 2 of those, I'll come up with your grade for those questions. But do your best to show me that you have improved since the midterm, that you're more competent than you were before. So really what I'm trying to get at there is if you don't know how to do the problem, don't just leave it blank. If you leave it blank, that's going to tell me all I need to know about how much you've gotten out of the class. That kind of makes some sense. Okay, so questions about and then the exam will be, all, short answer essay in programming. No multiple choice or true false or fill in the blank. I don't do those. So questions about the exam format in general. Go ahead.
Is there going to be more than 10 questions, or is it going to be 10 again?
I would expect there would be 10. I haven't written it yet, but in that ballpark. Historically, my exams have 10 questions in it that way because I can easily divide 100 by 10. So that's in my realm of capability. But if I bump into a question I really want to ask, there could be 11 or 12, but I would expect 10. It's probably going to be a decent bet. Anything else? All right, so let me kind of, we'll fly through our slides here, and I'll kind of, again, highlight the things that I think are going to be important for you to understand, because this is that same process I'm going to go through when I write this exam. Okay? When I write the exam, I'm going to go through and, kind of say, okay, well, this is something I want to make sure they still know, that kind of stuff. So, I'm going to kind of assume that you pretty much know the beginnings of Java and things like that. Is it possible I'll ask something about how humans solve problems? Yes, but I would say it's not high on my priority list. I would assume that at this point that's pretty much ingrained. Same thing, what's a programming language? These are some of this remedial stuff I probably will not ask unless I'm just searching for an extra question. Something like that, which I doubt that I'll have too much trouble coming up with. Same thing, some of these basic things, variables, literals, some of the evolution of our languages. I could ask a question if we're kind of searching for something within some of this remedial stuff. Something about, describe the difference between an object-oriented language and a procedural language in terms of, maybe instead of a telephone, I give you another example, in terms of a house or something like that. Kind of show me that you can, abstractly describe the difference between procedural and object-oriented languages. Certainly being able to look at functions, understand how they're written, the anatomy of a function. So there could be a fair question for me to ask you to write the method header for a method called this that takes in these parameters and returns this. Not even implementing it, just the method header. And that would not count as a programming question. Just asking you to take a word problem, write a method named addNums that takes two integer parameters and returns an int. Show me that you can write that method header. Okay, int addNums, int a, comma, int b. That type of thing. Let's see. Again, I wouldn't ask you to do the whole bit thing, which is an 8-bit number, a 16-bit number. If I ask something related to the primitive types here, it would be a question along the lines of, I don't remember if I asked it in the midterm or not. I'd go back and look at that. If I did, I probably wouldn't ask it again. But something along the lines of, why does C have so many different ways of holding integer values? It was the Y2K bug, that guy. Let's see, another thing I could ask is why are characters unsigned? Because they index into the Unicode character set. So the Unicode character set holds 65,536 unique characters, and we don't need to hold negative numbers for that. So that's why chars are actually represented as unsigned 16-bit integers to index into those. That might be a fair question. But I wouldn't ask questions about how many bits things have, things like that. If I asked a question about the char primitive type, it would be, why are chars unsigned integers? Because they only need to hold positive numbers because those numbers map directly to characters in the Unicode character set. Something like that. Let's see. I could see asking things about data representation languages, specifically JSON, which we've been working with more recently. So for instance, I might give you an object and tell you, or I might give you some information and tell you to organize this information in proper JSON format, where there might be multiple correct ways you can solve it, but you're kind of having to show me that you understand how JSON works. You know, that you have name value pairs. Some things that, name value pairs can be, the names are always strings. The values can be numbers, strings, objects, or arrays. So take some data, show me that you know how to represent that data in JSON. I could see that being a pretty good question. Okay, not write code to convert it to JSON for that one. Well, I mean, that really actually wouldn't be that bad. Not parsing JSON, but to tell you to output an object into JSON, that's far easier than parsing JSON. But what I'm talking about here is prove to me that you know what JSON is, and if I give you some data and I say, show me how you might represent this data in JSON, be able to draw me some reasonable representation of that JSON, kind of like in our cave JSON. We've just arbitrarily picked a format to kind of store our cave information, but there certainly could be 50 different ways of us storing the same information, right? We just kind of chose this way of leveraging JSON to represent it. So I would give you some data, say, give me your best shot at this. Tons of right answers, but show me you kind of know what the use of JSON is. Okay. I do like number conversion questions. Yeah, they commonly show up on almost all my exams. So, yeah, I would be able to convert between bits and bytes and gigabytes, and also between various bases. I probably wouldn't ask more than one of those, but I should be able to ask you to convert the decimal number 65 into the binary number equivalent, or I should be able to give you a hexadecimal number and tell me what the decimal equivalent is. I should be able to give you a number of gigabytes and ask you how many kilobits that is. Those types of things. Being able to convert back and forth between various numeric bases and various computery metrics. Okay. So that's this slide here, and then our number conversion stuff that kind of comes up in a little bit. I won't ask anything about the anatomy of a Java program. I pretty much assume that you already know that. Certainly you need to understand what pointers are. I could see giving you a scenario, maybe even having a little picture that shows kind of, or even giving you some lines of code that has an array, which is stored as a memory address, and make some changes or something like that, and ask you what the value of some variable is at the end of these 8 lines of code, proving that you kind of understand how pointers might work, how things might change with pointers. So certainly be able to read some code. The concept of side effect, you should also understand. That's kind of what I was just talking about, where if I pass an array into a function, because that array is passed by address, changes to that array will have a global impact. I mean, obviously you'll have to do if statements on there, but I probably won't ask you a specific question about if statements, but you should know how to write an if statement. I won't ask you anything about bitwise operations. I wanted you to know that they exist, but it's not something that's used very often. Certainly, you need to be able to answer those questions. Class methods versus instance methods. How can you identify them when you see one being defined versus see one being used? Don't miss that one. That will certainly show up as a question on there. Something in that, dealing with that idea. I could show you some code and tell you to show me how to call that method. I could show you a method being called and have you tell me, is that a class method or an instance method? All sorts of different ways of approaching that same idea, but be able to identify class versus static stuff and be able to explain how you identified class versus instance stuff. Probably won't talk about compilers. You should be able to write a constructor. I should be able to give you, maybe for one of the programming questions, give you a scenario of a certain object and tell you to define that object and write an appropriate constructor for it. So maybe not actually implement, a bunch of other functions in there, but at least here's the attributes that this object needs to hold, and write the constructor that kind of properly builds the starting point for that object. I should certainly understand this keyword. I don't know if I'll ask a question specifically about it, but you need to understand it. Same thing with public, private, protected. Understand the use of those guys. And in conjunction with that, the idea of a getter and setter, what they're for. Certainly be able to work with arrays. This starts getting into our pointer stuff. So I could see if I gave you some code and asked you to tell me what the output of this program is or something like that. I could see it involving arrays or something like that. So you're proving that you understand how pointers work, that kind of stuff. You should know what the new keyword is. Every now and then I'll throw that polymorphism question in there so you should know what that one is. I might give you the description of what polymorphism is, more than one method with the same name but a different number and or type of parameters. Or I might ask you to define polymorphism, or I might give you a scenario and say, what's this an example of? That kind of stuff. Okay. We talked about merge sort as well, right? Yeah. So, maybe some questions involving bubble sort or merge sort. I probably wouldn't ask you to write one specifically on the exam. Not that I don't think you could, or not that I don't think you should be able to, but, specific algorithms like that are more, not necessarily memorization, but you already know the solution. You just have to write the equivalent code for it. So I want you to show me maybe that you understand how a merge sort works. With the merge sort is kind of follows this idea of divide and conquer. Just keeps dividing your data up until it becomes trivially sorted. Then it merges them back together. And under what condition is merge sort considered to be fast? So it's when you have multiple processors or multiple threads or multiple computers, because you can split the sorting tasks up among multiple pieces. Okay, where bubble sort is much more linear. We're not, it's a one-man job, if you will. So generally speaking, bubble sort is considered to be relatively inefficient, but effective, and computers are pretty fast, so not the end of the world. So more about appreciating the difference between sorting algorithms, and I could even ask you, kind of a more of a hypothetical question. Assume that you have this scenario and you have a choice between using a bubble sort and a merge sort. Which would you use and why? So if you choose bubble sort, explain why you're choosing bubble sort. Probably going to be something along the lines of, the amount of data is relatively small, so it's going to sort fast anyways, or the amount of time it takes to sort is going to be relatively insignificant because we're not sorting that often, that kind of stuff. So bubble sort properly sorts but takes extra time. We may or may not care about that for some things. Maybe the scenario lends itself to merge sort, where we say, okay, well, we have data coming in very, very often, and the data set is being supported by a bunch of computers, or if I give you this scenario where this thing's running on a supercomputer or Google's computer cluster or something, where you can assume the data is accessible by 20 different computers, all of a sudden merge sort lends itself to that type of problem because you can divide the sorting up amongst a zillion computers. Let's see. Certainly recursion. I could see possibly a programming question on recursion, but maybe a substantially higher possibility of me giving you a function written in recursion and telling you to tell me what the output is, that you can read recursion, follow what it's doing, and how does this code work, be able to trace a program. All right, I could see that being kind of a common type question on the exam, where I'm going to ask you 3 questions for you to write some software. There might be several other questions where I want you to look at a function and tell me what the output would be for the following lines of code, something like that. So be able to read code, which you should be substantially better at right now than writing code. Okay, so all of you should be able to read and follow code. I could see a question on Git and GitHub, just kind of what's the purpose of that thing? What's the difference between Git and GitHub? If I need a filler question, that would be a decent one. Okay, so now we started getting into this idea since the midterm of how do we put all these things together that we've used before. So now it's we learned about all the Legos, and now we started building something with those Legos. So we used JSON. We used all sorts of different objects and had these objects connecting with each other. So this has been much more applied stuff since the midterm. So all these things have been done to reinforce what we learned prior to the midterm. So we had all sorts of different guys, players and things like that. This is where we introduced JSON, so definitely need to understand JSON. I wouldn't ask you to write any XML, but you should certainly be able to understand JSON versus XML. So XML is very verbose, stores the same kind of data in a lot bigger file, if you will, where JSON is the current cool kid. But if I were to ask one question on JSON, I could see it being less about XML and more about, here's some data, give me a JSON representation of this data, proving that you know what JSON looks like and you could write it if you had to. All right, so here's our example of XML versus JSON, where the same, this is much more readable over here on the JSON side of things, and also we have a lot less fluff. All right, so we started dealing with more object-oriented concepts, so I can certainly see there being a possibly a programming question, but definitely a question on the idea of inheritance. So specifically that protected keyword and how that plays into inheritance, as well as when we would use inheritance and when we wouldn't, and that type of stuff. So I might give you a scenario question for one of the programming questions that says, we have 2 different kinds of animals, or something like this, and create 3 objects for this using inheritance, representing cats and dogs, or whatever. So maybe it's a cat and a bird. Both of them are animals, but birds are a little bit different than cats and have certain features. So divide it up like that. So I would give you some sort of scenario and say, show me an example of inheritance with this problem. Okay, and we kind of saw that in our world when we dealt with kind of this global JSON variable, where our JSON variables just had a name. We said that every single JSON variable has a string that is a name. Then we have different types of JSON variables. We have JSON string variables that have a value that's a string. We have JSON number variables that have a value that's an int. We have JSON object variables that have a value that's a JSON object. And we have JSON array variables, which is has a value that's an array of JSON objects in our world, right? Official JSON actually lets it be an array of anything that of JSON values, but for us we did it as objects, which is fine. I won't go any deeper than that. But understand that that's an example of where we used inheritance. We chose to implement one class here, JSON variable, as an abstract class. And you should know what abstract means. Cannot create an instance of it. So we're just using that guy as an example of as a building block for inheritance. And then we created our specialized versions of JSON variables off that base. Okay, so definitely be able to show me you can handle inheritance. There's our abstract class stuff. Specifically abstract methods as well. You know, the purpose of an abstract method. You know, if I were to ask you what is the purpose of an abstract method, we would put it typically in an abstract class, or at the very least a class that other classes inherit from, which forces the implementation of that method. So abstract methods do not have an implementation. So we had, I think, an abstract method inside of JSON variable, which was what, 2JSON or something like that. And we didn't write it in there. We just said, this is an abstract method, so anybody who's going to inherit from JSON variable has to write this. If they don't, Java's going to scream at them. All right, so that's the purpose of an abstract method, is being able to force your children to have to implement some extra things in order to be children of this class, in order to inherit from this class. We talked about design patterns. Certainly I could ask a question about what is a design pattern, what's the purpose of them. We talked about MVC, observer, and singleton. I mean, I would say they're all fair game. I wouldn't get that deep into it. I would probably, we did use singletons in our code, right? So if there's one that I probably hold in greatest esteem, it would be the idea of a singleton and why we would use that. You know, how we use singletons, when we would use a singleton. So the idea is if we need multiple objects in our program to all be able to share data between each other, throwing it inside of a single object that they all have access to, i.e. a singleton, can be beneficial. Okay? So maybe what are design patterns in general is certainly something you should know, and then maybe some more specifics about uses of singletons. You know, why do we choose static variables for our singletons as well as opposed to having instance variables in there? So, you know, what's the problem? If our singleton is implemented as instances, then at some point we have to create an instance of our singleton and pass it from object to object to object. If we create it as one giant silo that just has a bunch of static stuff in it, all that stuff is constantly in existence up here. And all these guys can just reference the one copy of those guys. All right, so that's the point of a singleton. Okay, so understand design patterns in general, really an appreciation that it just means something very generic. A reasonable solution for a common problem, whatever that means, or a good solution for a common problem. And then specifically, we covered a couple of interesting design patterns, but the one that's most poignant for us is the singleton. We probably saw, well, we were kind of getting towards maybe where an observer maybe means something to us. So those of you who are going to do the Android thing over break, you know, we're probably going to have a situation where a monster wanders into a room, and if you're sitting there playing the game, you should probably become aware of that, right? So you become an observer, but you're not just standing there waiting for a monster to walk through the door. You're kind of chilling, doing whatever you're doing. Maybe in a real game you're crafting or something like that. Or you're solving a puzzle, and monster comes into the room. You'd kind of like to know about that before he comes up behind you and starts slashing. Okay, so that would be kind of the observer design pattern. MVC is certainly something we'll talk about quite a bit in the Android stuff, and also in your future classes. Next semester, I plan on using the Android development, Android Studio for a lot of our projects, to kind of give you, the nice thing about that is you get to take, instead of writing all these console programs, now we get to have programs that are running on, you know, something graphical, so you get kind of a more advanced feel. I technically prefer iOS development, but that requires that all you have a Mac, or you have to come into the lab, which I'm not a huge fan of the lab. But in any case, so Android, doesn't matter what kind of computer you have, you can do it. So we'll do Android, and it's fun too. They're both. It's not like it sucks. Just I think iOS is exceptionally good, where Android is just pretty good. So in any case, MVC makes a lot more sense in there, where in here, our interface was our little text-based world. So that wasn't overly complex. So MVC just says your interface should live in one place, your code should live in another place, and we just have interesting ways of making those guys communicate with each other. Where in our code, we're maybe seeing the problem, why MVC is needed. Right now, where does our interface live? It completely lives inside of our player object, right? It lives inside of our implementation where player knows how to spit stuff out to the user. And then it actually lives throughout our application. Rooms know how to tell the player that's in the room how to display something. So part of our interface lives inside of room, right? So we have basically our interface just intermelded through our entire application now, which we would say as our application gets more and more complex is certainly going to become problematic. If we want to change something in our interface, what do we have to do? We have to go find which of our 14 million objects that little part of our interface was in. And the room is telling me about this stuff. So I need to go into room, find the code where he's telling the user about that, change the text up so he tells the user something else. And now our interface is updated. Well, when we get into Android, you're going to see that we design our interface in one place, we design our code in another place, and then those guys talk to each other. So if we want to make a change to our interface, we go and change our interface. We don't have to go and find the code in our object that makes that modification, or at least we're not doing that very often. So MVC becomes a much more important thing when we start creating user interfaces that are meaningful. Now that we have this programming as a skill set, in our wheelhouse, maybe not under our belt yet, but in our wheelhouse, now we can start saying, let's start making interfaces that are meaningful and having those two guys kind of evolve together. So MVC is probably not something I'm going to focus on the exam because it's not something we're being bombarded with on a daily basis, but we're starting to feel the pains in our current application of why something like MVC is needed. Because certainly one thing that we want to feel from this application we've worked on since the midterm is we would say that this application in terms of what it actually does, we would say it doesn't do that much, right? Yet it's substantially more complex than anything we've done up to this point. It's starting to get unwieldy, okay? So we can imagine then, what if you were on the team to write Microsoft Windows, which does a lot? Would you say that application is probably a little bit more intimidating than our cave crawler? Yeah, probably. All right, so starting to get comfortable in that environment of more complex things is going to be important for us. So MVC is going to make more sense probably next semester. Know that it exists. Probably won't waste a question on it. Might waste a question on singleton or design patterns in general, or combine those two into one question or something like that. Okay, so here's our example of our singleton for our caves. Keep all of our stuff that needs to be shared between players and rooms and the cave itself all in one place. Oh, then we're here. Okay, that's probably a pretty good covering of the exam. Hopefully I've kind of gone through and pointed out highlighted the areas that I think you should focus on, and maybe told you the areas that it's all important from a programming as a skill set perspective, but for the next week you're kind of in the mode of what do I need to do to get a good grade on the exam, right? Those are two very different things. Okay, so one's the video game that is being a student, and the other one is the video game that is how do I become a great programmer 10 years from now. Okay, two different goals. Short-term goal is how do we do well in this exam. So hopefully I've kind of highlighted the places that I deem to be more important things for you to spend your unlimited amount of time between now and next week. We all have unlimited time, right? You don't have anything better to do. I gave you free time. You didn't have a homework assignment today. I could have said, fix my mistake. All right, so questions about the exam? Or anything you want me to go over again? If we don't get to the cave today, we don't get to the cave today. We'll fix that with the Android group if you want me to review anything from the semester to reinforce it, something you don't understand, I'm happy to do that. Go ahead.
In order to do an abstract class, you have to extend it to a variable, correct?
Well, so kind of the idea would be this, is we would make, so let's go a couple of routes here. So the starting point would be this. To make a class abstract, in order for us to syntactically say a class is abstract, we would just say abstract class, maybe we call it base class. Maybe that's the name of the guy. Or the example I was using when we were talking about it, maybe it's called animal. Abstract class animal. All right, so that's all it takes to make a class abstract, is using this word. Okay, that's it. All right, but when we do that, if somewhere else in our program, maybe, you know, here's our another class, and maybe we have our class driver, just to kind of put these guys in perspective. So we have our class driver, and just for the sake of space, let's pretend we already have a main method in here, if that's cool. So I am not allowed to do this. I can't say animal A is equal to new animal. That's illegal because animal is abstract. Now, if I had a class called cat, let's say, so let's throw cat over here, and let's say cat was written like this for right now, and let's assume there's some stuff in here, okay? I could, so this is, we're going to say this is illegal. Cat C is equal to new cat. This is legal. Nothing wrong with that, because this guy's not abstract. Okay, so abstract makes it off limits to directly create a copy of it, create an instance of it. But by making it abstract, the whole reason we would do that is so that we can come in here and say that a cat extends animal. So even though this line is not allowed because it's abstract, cat, this guy here, is still allowed. So I'm kind of indirectly creating an instance of animal by creating an instance of cat, because a cat is an animal. That make sense? So that's abstract classes. As opposed to this, if I come in here and I say we're going to have a abstract void speak, something like that. So all animals know how to speak. Cats meow, dogs bark, like that. All right, so all animals need to know how to speak. At this point, without changing any of the rest of my code, Java's now screaming at us, because it's saying, wait a minute, cat extends animal, which is cool, but animal says if you're going to be an animal, you have to know how to speak. So that means we would have to come into cat, and we would have to have a void speak method, and this is where we would actually implement that method. Notice it's not implemented over here, it's just kind of prototyped. You have to have one of these guys. So over here we would say something like system.out.println meow. All right, so that's how cats speak. So now we can take this line out because that line's illegal, right? Well, we'll leave it there just for the notes. Now I can say c.speak, because anything that is an animal will be able to speak because the abstract class animal has mandated it. So since cat is an animal, it must be able to speak. Java polices that because we set it up as a mandated method. So we have implemented that in cat, so we can tell our cat to speak, and the cat will say meow. Make sense? So that's the use of abstract methods as opposed to abstract classes. Abstract classes exist as building blocks for other classes. Abstract methods exist as requirements, establishing requirements for child classes. Now, having said that, does it make sense to have an abstract field? This would be kind of an interesting question. This would be a good exam type question. Whether I'll ask it or not, I'm not going to promise anything, but if you understand the idea of abstract classes, you understand the idea of abstract methods, now I'm asking, about that third guy. Can there be abstract fields? Does it make sense for a child class to be forced to have a specific field? How about I give you the answer and then you tell me why? The answer is no. It does not make sense. Why not? Why should I not be able to do this? Abstract string name. And let's pretend I put protected in there. It's not required, but we probably should, but I don't have space. All right. So abstract string name. Why does that not make sense? That is saying that cat, this guy here, must have a variable named name. So I'm telling you this does not make sense. If I want cats to have a name, what do I have to do in animal? Just that. A cat is an animal, therefore he gets all the fields associated with animals. So a cat already has a name. He gets one. We don't have to require it to have one. He's going to get one if we write it over here in animal. This guy's going to have a variable named name. That's how our JSON variables worked, right? We wrote that abstract class. We said all JSON variables have a name. They all have values, but those values are different. So we can't require it to always be a string value or a number value or something like that. We're just going to say each of those individual guys, they'll decide what their values look like. But every single JSON variable has a name. Make sense? So having a field be abstract doesn't make any sense. If we want all animals to have a name, all we have to do is this. Now all animals get a name. The second cat extended animal, he now has a name. We didn't actually set it, but this is legal code. C.name, C.name like that. Because I didn't make it protected, we could access it anywhere. All right, so he has a name. And then maybe what we do in here is the constructor for cat. This dot name is equal to name. Maybe look something like that. All right, so this is legal over here because a cat does have a name. Even though we didn't write it up here, it received it from animal. So this guy gave cat that name. All right, but now this line is now illegal. Why? So let's say on an exam I gave you this scenario. I showed you the animal class, I showed you the cat class, I showed you this driver, and I asked you, why is this line illegal? This should be a free point on the exam, just so you know where you should be when you're prepared for this exam. Easy, free, toss up, 10 points in the pocket. Why is this line no longer legal? What's this guy? What kind of animal is that? House, car, constructor. Those are your options. That's why I don't do multiple choice. That's a constructor, right? Isn't this me calling the cat's constructor? What does the cat's constructor require as a parameter? A name. Have I given it anything here? That's why it's illegal. If you're going to call the cat's constructor, you better call it right. Okay, I just created a new constructor. If I don't give a constructor there, I get a no argument constructor that does squat. Okay, that's why this line of code used to work before I put that in there. When I had not explicitly written a constructor for cat, I got one just so that syntax down there would work. So I could use the new keyword to give me an address. But the second I decided to be a decent programmer and write an actual constructor for cat, at that point in time, I've now erased that freebie. Okay, I said, look, I got this. I wrote my own constructor. Now I know what cats should be. Okay, cat gets a name because he got it from his parent. So we're going to go ahead and when we build a cat, we're going to build a cat given its name. So now I need to pass in the name for the cat. Of course, we'll choose the best cat name. That's my cat, by the way. Well, my favorite cat. I have more than one cat. I have favorites. My wife says you're not supposed to have favorites. Is that true? I mean, I like clearly have a favorite. When we had 3 cats, there was a pecking order.
I think it depends on the animal.
Really? Really? Like in what? Where are you allowed to have favorites?
It depends on I feel like cats you could have a favorite because they're very different from dogs and personality wise.
Really?
Yeah.
I mean, I think don't all animals have yes, they're different than dogs personality wise. That's probably a true statement, but just like dogs have unique personalities, so do cats. Like I think non-cat people think that cats are all like the same, just like jerks. Oh, and Gracie is. Okay, but cats do have the same kind of unique personalities. Except my cats are the 2 I have left are both 25% lynx, so they actually act a lot like dogs. They chew on shoes and stuff like that, where cats typically don't do that. But okay, so from your perspective, you're allowed to have a favorite dog, but not a favorite cat, or is it the other way around?
I think it's the other way around.
Okay, so dogs should all be on an equal playing field because they're like more like kids.
Well, no, not technically.
So you're saying you're not allowed to have a favorite kid?
No.
All right. Now, is that a true statement, or is that just like the politically correct thing to say? I think my mom says that. I think most parents would probably say this, that they love all their kids equally, but they love them differently. You got the misfit, and then you have my brother. I was a discipline problem, if that doesn't come as a surprise. I was like perpetually grounded when I was younger. And then I would escape. And it would just keep extending. It was a recursive procedure. They would just tack on another week and I'd escape again. That was back in the days when I could fit out of a window. I actually think about that now because my parents don't have that house anymore, but it was like kind of like a prison because the windows to my brother and my bedroom had like bars over it, but it wasn't like completely barred in. It was like almost like a decorative thing. So you had to get out the window, then kind of had like squeeze up around it. So it wasn't like flush up against the window. It was like, almost like curvy coming out of it, maybe 2 feet. I mean, so like today I couldn't get out the window. But back then I could get out the window and snake through the curvy bars. I wouldn't be able to escape today. I could probably plow through that wood door. All right. So, in any case, yeah, best cat name. So, in any case, in order to properly create a cat, we have to provide it the required inputs. And the cat constructor says it needs a string to work. So, I'm going to give it a string. Now it's legal again. That makes sense? Those types of questions would be fair game. Okay, so that should have been pretty clear. What should work and what should not work here. You should be able to look at these 3 things. These are 3 very simple classes. Not a lot going on here. You should be able to look at these and say, okay, well, based on how this guy is written, now I know what this guy does, and based on how this guy is written, now I know how this is used. Okay, and if there's something that was a class method or a static method or a class method or instance method in here, you should be able to call those as well. It would be completely reasonable on the exam. In fact, I'm actually thinking this is a great idea, so you might want to put a little star next to this. For me to give you kind of given code at the top of the exam, and then have several questions to just reference that code. You know, asking you, what does this do? What does this do? And it would be something like this. I mean, maybe I give you this on the exam, and maybe I number the lines down here. So maybe this is, you know, maybe this is line 1, for instance. And I ask you, is line 1 legal or illegal and why? Something like that. Is line 2 legal or illegal and why? That kind of stuff. That would be a great type of approach, I think, for this exam. You should be able to read this code easily. And for the record, 2 tea bags is enough for 70 ounces of water. Because I got sick of brewing coffee, so I just decided to fill it up with hot water and throw tea bags in there. All right, other questions. So that should I think that thoroughly covers abstract, as well as inheritance, as well as constructors. I mean, this one slide here is, I think, pretty telling for maybe what you know and what you don't know if you struggled with this conversation. Go ahead.
So does the super thing come in when you're defining the cat's fields, not its constructor? So you'd say like super name, or is that?
No, it would just be in the constructor. So along those lines, because I did not write a constructor over here in animal, so to use super, as you're pointing out, it would be something like this. I'll show you both ways we might use super. We might say, what's this guy called? Animal. Public animal string name dot name is equal to name. So maybe in our abstract class, instant weight loss. So maybe in our abstract class, we go ahead and create a constructor that takes in a name and sets that name equal to whatever was passed in. Now, this constructor cannot be used directly because this line of code is illegal. So I can't say that. It's not that I'm calling the constructor incorrectly, it's that I'm not allowed to create instances of animals because animals are abstract. Okay? But who is this constructor for? It's actually for children of that class. So now I can call upon that constructor by calling it in the very first line. So this guy must be on line 1 of cat's constructor. If I choose to leverage my parent's constructor, I have to do that first inside of the child's constructor. I don't have to. I could choose to go ahead and instead of using my parent's constructor here, I can choose to reinvent the wheel and still say this dot name is equal to name. I could just duplicate what would happen over here rather than call upon the parent's constructor. But that super keyword comes into play. Whoop, like that. If I want to go ahead and leverage my parent's constructor. Similarly, that super keyword would come into play in this case. So I'll show you our hidden agenda here. So let's say string to string. So this would actually be a good question. Let's call this guy line 3. Is line 3 legal? Let me come back down here. So I'd ask the question, is line 3 legal, and what is the output of line 4? Man, I love this idea for an exam. Giving up all my good questions right here. So let's start with line 3. Is line 3 legal? How many people think yes? Full participation. Even if it's a guess. Sometimes you're just going to have to guess on the exam, right? If you're, all right, so we got, is that like 7 1/4 people? All right, who thinks this is not legal? All right, so 2 1/8. Oh, 3, well, it's 2 2.5. 2.5 now. So in church, don't they tell you, put your hand way up there? They don't do that? Really? My pastor drags all the little kids up to the front, and I want to go up there, and my wife doesn't let me.
So you putting your hand up.
I don't know. When he says, he says good morning and stuff to the kids, and the kids like they say it real like softly, and then he yells at them. He says, "I can't hear you," and they have to say it louder, and so they do the same thing like in Sunday school. You got to put your arm up higher. Like when you have a question, you can't just do this little thing here.
I'm so confused. When would you have to put your hand up?
Huh?
When would you have to put
No, you're supposed to raise your hands for this voting.
But what's the answer in church?
I wasn't voting. I know the answer. At least we hope I know the answer. That had to be a Christian worldview point. All right. All right. So line 3. So we kind of, let's say the class was split. It was a split vote. Is this legal? When I say super dot, so his question here was about super, right? So when I say super, who am I talking about? I'm talking about my parent, correct? And who's this guy's parent? This guy's parent is animal. Does animal have a method called toString? Ah, the answer is yes, it does. We didn't write one, but there's a little invisible dude up here, right? Extends object. So an animal extends object. A cat extends animal. So a cat is an animal as well as an object. So a cat has his own toString method here, and that toString method is automatically called by the println method, right? So println, when println is passed an object, in this case I'm passing him an object called C, he automatically tries to call that object's toString method. And he knows for a fact that is legal to do because every single object in Java at some level comes from object. An object has a toString method. So cat wrote its own toString method, a more local copy of it. So this guy is effectively calling c.toString. That's what's actually being called there. Okay? So he has a toString method, and what does this method say to do? It says, well, it's supposed to return a string. So this guy's going to return this string, cat, followed by an arrow, that's the string we're returning, concatenated with whatever my parent's version of toString returns. So we look over here in the parent and we don't see a toString. So we're not out of luck yet. Then that parent checks with his parent. We pass the buck because this parent, animal, inherited all the crap that objects have, including a method called toString. So over here we effectively have an invisible method called toString. Okay? That actually was written by the Sun Microsystems people inside of the object class. So this is legal, this line of code. And what will the output of this line be? So line 4, what will that look like? I gotta get better at drinking out of this. It comes out so fast.
Yeah, it needs a straw.
I just figured it out. I'm tipping it too much. That was better. You have to. It's gonna be a 4-degree tilt. Anything more than 4 degrees, and it's bad.
Well, it's gonna matter how much liquid's in it.
70 ounces.
4 degrees.
No, I don't think it actually does. It's weird on the inside because I can carry this thing like it's a suitcase without it leaking. It's like ramped up. So I don't. Well, no, I get it. It does matter a little bit. So if you have it just this much, yeah, you'll have to turn it more.
Yeah.
So it's going to be 4 degrees times,
Percentage.
yeah, the inverse percentage of how much is in there. Yeah. All right. Now I nailed that, so you have to nail this one. So what's the output of this line of code?
I should get extra credit on the final for that.
Are you going to need it?
Yeah.
I have high expectations for you.
That's not smart.
Really? That's not smart. You don't want me to have high expectations?
No, I want you to have low expectations. That's why if I do slightly better, like, oh, you actually know some stuff, and then you feel bad when you want.
Well, you want me to take pity on you? That's it? Go ahead.
Wouldn't it equal now? Meow?
Meow?
Because you're at the end of the string.
What would output meow? Speak would output meow. So if I said c.speak, we would get a meow. Okay, because I'm calling this function called speak. But in this case, system.out.println, C is effectively calling c.toString. That's what's actually happening under the hood. If we went and looked at the implementation of the println method, we would see there's 2 different versions of the println. Well, there's a bunch of different versions of the println method, but out of those bunch, we have 2. One that takes a string, that knows how to print a string. That's the one I'm calling right this second. I'm calling C's toString. And then we have one that takes an object. And the one that takes an object calls the toString method of that object. So effectively, what's happening under the hood here, when I just passed it in C, is that toString method is being called. So that means this method's being called, and I don't see a meow in there. So no meows this time. If I wanted a meow, I could actually I could say this.speak in here, and then return. Then I would get a meow. Okay, but no meows right now. Anybody else just think about Super Troopers? Anybody in here seen Super Troopers? There's a scene in there where the cops are screwing with the people they pulled over, and he goes up and he's supposed to be saying the word, do you know why I pulled you over now? But he just keeps saying meow, and the other cop's supposed to count how many times he says meow. And they had like a bet who can, if he can say meow 30 times in this pullover or something like that. So, what do you think's so funny, meow? First 10 minutes of that movie is like the best. You only have to watch the first 10 minutes. And the cops are pulling over, passing him on the shoulder. And all right, so what's the output of this line going to be? Should be another freebie. Seen this a zillion times. Okay, where's the Gracie come from? So I'm in agreement with the cat arrow part. So far, so good. We're going to see cat arrow on the screen. But then what's this guy do? This guy concatenate something, right? Okay, so it's going to be cat arrow followed by something else. And what's that something else going to be? Whatever this guy boils down to. Okay, whatever that guy boils down to. So super.toString. is going to look in here in animal and look for a toString method. Does he find a toString method in there? No. So he's going to go to his parent and look for a toString method. And what does the toString method in object return? I think I've usually referred to as creepy memory address, right? Okay, so this guy is going to be cat arrow, then followed by some creepy memory address, representing what an object's going to say, look, this is the best I can do. If you've gotten to my version of toString, what I'm going to give you is a string representation of this generic object, which is his memory address. Okay, so this line right here is going to print out to the screen the result of c.toString, which is going to be cat arrow some memory address. That make sense? Okay. My golf date just declined. There's a job interview in Chicago. He must have gone long. So now I need a new golf date.
Where are you gonna golf?
I golfed on Tuesday.
I guess it isn't snowing.
It's like supposed to be 51 today. I actually played well. I shot even par and for 9 holes on.
Do you go to like nice courses or like crappy courses?
Well, not this time of year. Everything's a crappy course this time of year. During the summer, I play all over the state. Yeah, I hadn't played in like over a month, and I went out and I shanked my way to a bogey on the first hole, and then parred in and had 1 birdie. So.
The courses right next to campus. Really bad.
Well, I mean that's like a baby course. Missing links.
There's like 1 hole that's like 50 yards.
Yeah, it's a par 3 course. It's for like beginning golfers.
I don't know. There's like par 3 courses by me that are at least like decent length holes and everything.
Well, it shouldn't be that decent length. They're par 3s.
They're like at least 100 yards. I feel like 50 yards is pretty bad.
Well, not if you're a beginner. Are you a beginner?
Not really.
So you're good at golf?
I'm not good, but I'm not bad.
Or you want to play for your grade?
Yeah, I feel like I have a better chance playing that.
I guarantee you will not.
I'm doing my final. If I get like par, I get an A.
So we're going to play 18 holes for your grade. I'm a low single-digit handicap.
Okay, that's probably not smart.
I think you have a better chance on this. Yeah. With back spasms, I can still probably break 80. Yeah, so that's a bad idea. Yeah, I'm not the best golfer in the world, but I suspect I'm better than you.
I've only played for like 2 years.
Yeah, I'm definitely better than you.
But I think if you play somebody who has only played like a couple times, you're struggling.
That's true. But yeah, the worst people are the people who've played for like 20 years and suck.
And have no idea how to swim.
All right, so this guy right here is going to give us cat arrow followed by the memory address. Make sense why? All right, so that's our super keyword stuff, right? So we use super in this form right here whenever we want to leverage our parent's constructor. And if we choose to do that, it has to happen first. So maybe a cat has maybe another variable. We have private Boolean has clause, for example. All right, so maybe we go ahead and let the parent set the name. And then we take in a Boolean, let's just say clause. And we'll say this dot has clause is equal to clause. All right, we'll come down here, and Gracie definitely still has her clause, so that's a true. So we'll pass in Gracie, and then true for clause. We'll ask the parent to go ahead and set the name, and then we'll set the clause. This is legal as written. This is not. If you're going to leverage your parent's constructor, it has to come first. Okay? Otherwise, you would have to do it yourself here. This dot name is equal to name. That's legal again. But if you're going to let your parent do some setup, you got to let your parent do the setup first, and if you want to undo some stuff, you can then undo it. But it always has to come first. Make sense? All right. Anything else? Final minute. Going once. Going twice. I'll see everybody on Tuesday. And I've already got a couple of people who've shown interest in the Android thing. If you're still interested, shoot me an email this week if you can. That way I can put together any details. I mostly need to know, A, if you're interested, and B, do you need credit? If you need credit, we'll have to put together an independent study. If you don't need credit, you're just interested in doing it. Credit means you get credits, but you have to pay. Interested means you don't need credit, you're interested in the project, doesn't cost you a dime. Right? So it all depends on whether you want credits or not. Or whether you need credits.
Have a nice day, man.